So let's have a detailed look at a beta negative particle. So basically, a beta negative particle is a high-speed electron, and it's emitted with an antineutrino. And this is a massless particle, which means it moves at the speed of light. Now, the beta particle itself is a high-speed electron. It's moving at 20% the speed of light, and it has an atomic mass of 5 times 10 to the minus 4 atomic mass units. So, let's have a look. We'll see what happens. You've got a carbon-14 here with 6 protons and 8 neutrons. It goes through beta decay to release the electron here, the antineutrino, but it raises the number of protons from 6 to 7. We'll see why. And it decreases the number of neutrons. And basically the reason it does it is it changes a neutron, into a proton, an electron, high-speed electron, and a neutrino. Antineutrino, sorry. The reason the antineutrino is there, and that is to conserve mass and charge. So in this case, what actually happens is the Z, so the atomic number, increases by 1, and A, the atomic mass, remains the same, which means you've lost a neutron and gained. You've lost a neutron and gained a proton. So what are the conditions that this would happen? Basically, if the neutron to proton ratio is too high, so you've got excess neutrons, one will convert to a proton and release a beta particle. It has medium penetrative power, which means it can be stopped by aluminium, not paper. It'll go straight through paper. It has medium ionization potential, and it's deflected in EMF. EMF being electromagnetic fields, and this will be attracted to the positive poles, because you see you've got the negative electron, so it will go towards a positive pole. Now let's have a quick look at an example. So what we see here is that the neutron to proton ratio is too high. It's too many neutrons in our carbon-14. So our carbon-14 goes through beta decay, or beta negative decay, and what this means is it releases this beta negative particle right here, which is a high-speed electron. It releases the antineutrino over here, and this changes. Okay, so the Z, or the atomic number of protons, increases by 1, and the number of neutrons decreases by 1, so the atomic mass stays the same. And this is what we have. We have the neutron here, and it's what falls apart, and it releases a beta negative particle, which is a high-speed electron, and a proton. So a nice little summary here is that a neutron is actually a proton plus an electron. So this allows us to have charge and mass conserved. The antineutrino there is there to conserve angular momentum. Alright, thanks for it. See you later.